it's really to remind me what to demo. Most of this will be demos. So Runspaces. I'm going to assume nobody's used them, but if you have, feel free to share your experiences. I think they're a little bit seen as a little bit of black magic, if I can say that, as in difficult to get going, but they're actually quite easy when you get the hang of them. So who am I? I'm not going to read all this out, but basically my background is as a developer. So I wrote my first code 5 decades ago. I used to do Unix device drivers before I got into this Windows thing via Citrix. And my day job is mostly writing PowerShell for software vendors like those mentioned there and others, depending on what comes in. And I try and do as much as I can for the community in terms of scripts and presentations like this, so and get a few awards thrown at me. Okay, so why use Runspaces, or why not use Runspaces? The main reason is so that we can run stuff, that's a technical term, as in things, in parallel, so at the same time. So what do I mean by that? Well, I could go out and, if I do a lot of troubleshooting and health checking, I could go out and do stuff on 100 servers all at once, pretty much, depending on the number of threads in my thread pool and my CPUs available, but we'll talk about that. And that can be a lot faster than doing one server, then the next server, then the next server. Somewhere else it can be used as well is if you've got something which could be long running, if you're calling a commandlet, either built-in one or a third party, that takes a long time, as in perhaps it takes minutes. And if you think it hasn't worked, if it takes more than 10 seconds, then how do you kill it? Well, you can run it in a run space, which means it runs asynchronously. So you can control it and terminate it, and it doesn't block the main thread of your code. Now, PowerShell 7 does have for each object minus parallel, so it can do a certain amount of this parallelization. It's a difficult word, but I certainly don't use PowerShell 7 much for my customers because they have to assume the worst case that their customers have not updated PowerShell. So it's PowerShell 5 if you're lucky. Now there are jobs, so you've got start job and so on, but they start a whole new process. So they can be quite slow to start up, and that makes them very isolated from the other jobs that you might be running, which you might want. You might want isolation, but you might want them to communicate. And some commandlets do actually have a minus as job. So get Kim instance, I think off the top of my head, has an as job, so you can set it as a job. So it does make it easier to implement timeouts, but not many commandlets do have that as job. So I started with these about Runspaces about 4 years ago. I wrote a Citrix script to go and query a lot of Citrix machines. I found that sequentially it would take 15 or 20 minutes. So I used Runspaces and got that time down to about 3 or 4 minutes, because it can go and do a lot of that work in parallel and then bring the data back together so you can present it or work with it in your main script. And again, part of the demonstration, I'll show you how we get that data from the script. So there's a number of phases involved. It's pretty straightforward, and you'll see from my example code, which will go on GitHub later, that is pretty straightforward for each of these phases. So first of all, we have to create a run space pool. Now, all PowerShell sessions have a built-in default run space. So if I go over to here, so that's PowerShell, good old PowerShell 5.1, albeit in terminal, which has crashed a few times on me today, but let's hope for the best. So 5.1, and if I do a get run space, which is built in, I've not got any third-party component there, and that's part of the utility library. And you see I've got one run space, and that's what's actually powering this single session. So that's just a normal PowerShell prompt. A runspace pool is, as the name implies, a pool of run spaces. Now, there are various links in these slides, so I'll make this available via PDF at some point after today. So first of all, we have to create the run space pool. I'll go through the phases, and then we'll drop to the source code and step through all these phases. So we create a run space pool and initialize it. We load all the things that we need into that session or into that run space pool, such as what we're going to run, as in script blocks and potentially functions as well. We'll cover that. We actually run those script blocks that we've loaded in. So I might, in the demo, I'm going to be loading something like 10 different script blocks and running them all in parallel. And you'll see that actually loading them and starting them running is very quick. And then we have to monitor them. We don't necessarily have to monitor them. We can just wait and harvest the results. So those two steps there can be one and the same, and they are in my code. But you might want to, rather than just waiting for the results to happen, you might want to monitor and put up a progress bar or go and do something else. Because this is asynchronous, you can then go on and do other things if you need to whilst these jobs are still running. I use the word jobs, they're not PowerShell jobs, but I can't think of a better word. And then we just tear stuff down, and you'll see that's quite important just in terms of cleaning the environment. Okay, so let's switch to good old PowerShell ISE. Yeah, I can't hear your boos going, oh, use VS Code. Well, I'm old school. I have some problems with VS Code. If I do PowerShell 7 stuff, then yeah, I use VS Code, but ISE suits me particularly as I used to do a lot of work on site for customers, and you can never guarantee that ISE is going to be there. So here's a script that I'll use for the demos, and I'll put on GitHub. You see, I've been a good boy and put some comments in there. Take some parameters, and we'll invoke it very shortly. So here we go. So if we look at line 72, excuse me, I just need a drink for this sore-throated mine. This is where we create our session state, which we need to pass into runspace pool, which we create later on. Then why? I don't know, but that's just the way it is. This code has come from various places. I think I got some from Bo Prox. If you've heard of him, he's got some good articles, and I think I reference one of those, or the first of 4 parts in the slides. They're good articles. But the idea with this script really is you could take it apart and use the pieces yourself. I made this test script by copying and pasting from my production scripts, should we say. So and all the other stuff for the moment, I need to see the random number generator and stuff like that, but I don't need that for the run spaces, just for my particular demo, because I'm using random sleeps to show that this stuff does run in parallel. So I create a session state. There's a note there. I do use run spaces in some of my GUI programs where I have a WPF, a Windows Presentation Framework GUI, and it can cause problems. So you need to set the apartment state, which is just a case of $session state apartment state equals STA, as the error tells us, if we don't do that. But only for GUI stuff, which is why I'm not doing it here. Or that's the only need I've found for it. Now this is something we'll come back to, because this is quite important. This is how we can have a thread safe variables available between our different run spaces. So it might be the run spaces need to communicate by sharing data. I mean, they can communicate via events as well. But this gives us the synchronized means it's thread safe. So what we mean by that is that if I've got 2 things running in parallel, so running at exactly the same time, which is possible when I've got multi-core, which is pretty much normal these days, then I need to make sure that if both or two threads are writing to the same variable at the same time, it doesn't somehow get corrupt and get half of one value from one thread and half from the other thread. So PowerShell takes care of that for us with this particular structure. And I'm just going to have one variable, which I've aptly named stuff, because I like meaningful variable names. And that's just going to be a string array. Again, it can be whatever you want. My production scripts, I might have half a dozen, 6, 10 variables. Then we have to add that variable to the session state. So the session state I made earlier, to its variables. Again, let's actually drop a breakpoint in there so we can actually start to interrogate, look at these objects. Get that in the path so I can pass it some arguments. What should we have? You see the parameter block here has defaults anyway, so we'll run with the defaults for now, and we can add parameters later. I'll give it a varnish of a boast because there's various other messages coming out as well, much because I don't like write host very much. Although you can at least redirect its channel stream in PowerShell 5. And again, we'll come back to streams later, so we can see how we harvest them from the Runspaces. So let's run that. Okay, so now drops at this breakpoint I've put in. So we can see I've got a session state. Let's make that a little bit bigger. Take it, the font sizes are okay. Tell me if they're not, and I will make them larger. So this is my session state variable. As I say, I've just created it with a default. Let's put all these nice things in. What do they all mean? Don't worry too much about those. You can see we've got an apartment state that I mentioned before, which is unknown. Again, doesn't matter, it's going to work. And in the variables, you can see that we've got quite a few. And again, it's going to have inherited them from the environment. So we pass that through the format table. We'll see we've got a few, including my stuff, the one I added. Excuse me, sorry, I need a drink again. No alcohol, of course. Okay, so that's got my shared variable between them, and you can see it's inherited various other variables from the environment. The next thing is the script I'm going to use, or the script block, to be technically correct, if I move down to that, is here. So this is the script block that I'm going to run multiple copies of in parallel. And it does actually use two functions from the main script. Now, unlike functions called normally within the body of this script, those functions aren't automatically available to the Runspaces. So we need to load the definitions of those scripts, so they're defined here, into the session state, and therefore the Runspace pool eventually. So you can see here, I'm actually, well, deliberately only passing in one of the functions. So we'll see some error handling in a bit. And because we have, I don't know if you're aware of, one of the PowerShell drives is a function drive, you can actually just use get content that you'd normally use for a text file, let's say, to read the body of that function. And then we can actually add it to the this session state again. So again, don't really need to understand detail, but if you've got functions you need to call, then you need to make sure they're available. I mean, if it's a module, then you can just import the module. But if these are functions locally defined, like I've got here, they need to be put into the Runspace. Then the magic to actually create the Runspace. Let's drop another breakpoint in here. 1F9, you can do it. Perhaps you can't. Oh, yes, you can. Sorry, excuse me. So here's where we actually create the Runspace pool. Notice again, if this was a production script, I'd probably have a check to make sure that Runspace pool was created and wasn't null and throw a fatal exception if it wasn't null. But again, to keep the code fairly clean, I've left that out. So runspace pool, actually there's a easier constructor that only takes 2 arguments, which is the minimum number of run spaces and then the maximum number of run spaces. What maximum should I use? Difficult to say. If you use something very large, if I put 1,000 in there, doesn't mean it means I could potentially have 1,000 things trying to run at once. But if I've only got a 4-core, CPU or vCPU, then only 4 things can actually run in parallel at the same time. So a good number tends to be about the number of cores that you've got available, or vCPUs. We also pass in this session state that we've been building and adding things to, like our functions and our variables. And we pass in the host, which again is a built-in variable, which talks about effectively what is the host. In here it's ISE, but it would normally just be PowerShell itself if I was running it through a prompt. There are other things we can do to the run space, but that's all I need for this demonstration, and then we open it. But it's important, as per that comment, to make sure anything we do need to do is done before we open the run space pool, because once it's open we can't make any changes to it. What does opening it do? Nothing really, other than say, yeah, you're going to get some jobs put at you now. So the next bit now, number of jobs is parameter, if you remember, which I defaulted to. I can't even remember the default. Was it 10? Oh, good. Look, the telesense isn't working, and I can't type. Number of jobs. Number jobs. Yeah. Okay. I was close. Use meaningful names. Okay, so I'm going to run 20 jobs, it would seem. Okay, so there's a loop here saying from 1 to 20 for each of those. I'm going to say the number of the job here. So again, let's drop down here with a breakpoint, F5 it, so we can see that number of the job here is number 1, the first one. So it's created a new PowerShell instance, but not a new PowerShell process. That's quite important to understand, that this is within the same PowerShell process. It's just a separate PowerShell container, if you like. And then we set the runspace pool for that PowerShell instance to be the runspace pool that we've already created and opened. It has to be opened by this point, otherwise it will fail. Next thing we're going to do is to actually add the, it says add script, but I'm actually adding a script block, hence the curly braces here, adding all that in. So this will take a number of parameters that I can pass in, because all variables here are going to be isolated from the main script, so that there's no sort of automatic scope inheritance that we get with normal PowerShell, which I don't like, but that's the way it is. So I'll see what does this script actually do, or what does this script block actually do? Gets a random number somewhere between 1 and the maximum sleep seconds, which I think is defined as 20 in the default parameters. It then creates an object, custom object with its parameters and some other stuff that it's calculated. So we get the thread ID. So what thread is this piece of code actually running in? So that will help us see how the thread pools are actually utilized. And this is basically what's returned from the script, and we'll see that later when we see about the phases for monitoring and harvesting the results. So then actually does a start sleep, runs a couple of these functions. Again, this is purely for demonstration purposes. So we could be here, going and getting or performing commands on multiple machines. You can do whatever you want with it. I'm also actually, let's do that, bring over, if you're familiar with sysinternal's DPG view, but I thought for the hell of it, I may as well write to stuff here as well in the debug channel, because mainly it can be quite difficult to debug stuff when it's running in parallel, because you don't get the normal outputs that you would from a script if it's running in the main body. So being able to see what's going on inside the thread can be a little bit more challenging. So this line here, where we actually use .NET to write to the debug channel, as well as other things, or write into the debug channel. You can see I've started it. I was checking it early this morning. This is already right. This is some other process. This is the process ID. So we'll look for our PID 71396 later on. We add some stuff to our stuff. Yes, very meaningful, Guy. Thank you for that. What does that mean? It means we've got a string, and we're going to add it to this shared variables. Remember, I created this synchronized hash table with one entry, so that's effectively as a variable that I can reference, which is going to be an array. So I'm just going to collect data from each of the separate threads that are running, as well as actually returning some data. And again, that will become obvious, I hope, shortly, when we actually see what comes out of here. And then we end down here again. We don't need to exit or anything, because that's the end of the script block, so that the Runspace pool will know that's the last of the work that it has to do. This bit perhaps is a little bit confusing, but the reason for that is I've got some static parameters that don't change, that get passed into this script. So param1 and param2 are actually hard-coded, dare I say it. I should have made them script parameters. So you can see here, this is my initial hash table for passing the parameters across. So these are going to be the same for every instance of the thread, or each instance of the thread, but I also want to pass through the job number, which will be 1, 2, 3, 1, 5, I think. That's about all the German I know, sorry. I tried. So we add the parameters. So I take a copy of that hash table, the static one, add in an extra parameter, which is the job number, and then add that to the PowerShell instance for this particular thread. Remember, we're in a loop at the moment from 1 to the number of jobs. So there'll be one of these PowerShell instances for each thread. But again, not a new process. So that's why it's much quicker than jobs. So I set up the parameters. This is the key bit. This is where I actually tell it to go off and do something. Begin invoke. There are two invoke calls. As begin invoke, which is an asynchronous start. So that means it will carry on to the next line, or there is an invoke where it will block, wait for that to finish, which obviously then defeats the whole point of using Runspaces. So if we drop down here, so F5 to that point, notice now we've actually got some verbose output. And like some warning output as well. So this can get a bit confusing and a bit messy. So you see it's already messed up my prompt here, but I can just hit enter. Oops, I should not muted my Teams. I've got a script that does all this, by the way. Obviously it doesn't include Teams. Oops. Anyway, so now we're at this point. I've got a handle. What is a handle? Well, we'll see how we use that later. The handle tells me some things. So is it completed? Well, this one's actually true because it doesn't take long to run, because what we're doing is we're running however many jobs there were, 20, I think, and we're running sleeps. And what I want to try and prove here is that if I'm running, let's say the average sleep time is 10 seconds, if I'm running 20 threads, each sleeping for 10 seconds, then the actual total elapsed time should only be about 10 seconds. It shouldn't be 10 times 20, which is 200, which is what would happen if I ran them sequentially, one after the other. And we'll see that in the results. So what I do for that particular, well, I like to say, I call it a job. It's obviously not a PowerShell job, but I couldn't think of a better word. So what I need to do is to store the PowerShell instance for this particular one, because there's going to be a different PowerShell instance for each thread, and this handle to the running of it in a collection. So I'm storing that in this jobs array, which, if you remember, I declared it up here. So that's going to keep all of my thread details in so that I can query them later, check on their status, get their results, and so on. So what we'll now do is I'll remove that breakpoint, F5 it and remove that breakpoint. So it's now going to do this loop quite a few times. So we can see, we can see the output coming along and warnings and verbose. And again, this can be a little bit off-putting, but we can go and get that detail from each thread as well. So if you are outputting information, make sure it is identifiable and useful for that particular thread. So you see, I'm outputting the thread IDs for the jobs. So you can see that all 20 jobs have now gone in. What I will do is run this script without any of the breakpoints shortly, and you'll see how it works better in some ways, because obviously I'm stopping it and breaking it, then most things have actually finished. But we can see also this, it doesn't run in order. Yeah, so we can see just these calls to the panic function, as I called it. 3, 5, 11, 17, 9. So potentially random or randomish. So now we have an array of jobs. So if we look at jobs, again, let's just clear that. What is jobs? Is a array which should have 20 elements in it. Yep. And we were saving the PowerShell handle and the handle and the handle to the PowerShell. So if we look at jobs 0, we can see again, because I've been talking rather than letting it run, then it's completed, as most of them will have done. And then we also have its PowerShell. If I could type, that would help. And we can see the PowerShell side of things, and we can also notice this is something which we'll come back to later. It says had errors. Okay, it had errors, but I've cleared it now, but I didn't see any red, so I didn't see any errors. So this is something important to check with Runspaces: is did you have an error? Was it a fatal error? Yeah, did you get the results you needed? Are the results to be trusted? You need to make sure you go back and look at the error state. And again, we'll cover that later. So what we do now is iterate, as in look at each job. And the end invoke is a synchronous call. Excuse me, I need a drink again. To end invoke, which goes hand in hand with the begin invoke that we did to start, that we called to start the thread or start the script block in the thread. We now have the end invoke, because we've still got that PowerShell object because we saved it in our array. So end invoke is a synchronous call that'll wait for that particular job or thread, so the first one, to finish. And it needs a job handle, which again we saved, which is why we saved that particular handle. So if we step through that, now if I F10 it to step over, you see it comes back straight away. Why? Well, because it's finished. And again, I'm only assigning this to a variable here because I'm actually assigning the whole of the results to an array, something I do a lot of. I've seen a lot of this in code where, let's say, results is an array that you define. People go results plus equals, some new item. That's certainly with standard built-in array types, that's to be avoided. Why? Because that makes a copy of the array every time it adds a new element to it. So that can make it very slow when you're dealing with large collections. So I find the easiest way is to return the objects into the pipeline and then harvest them into this array. And again, I strongly type everything because I come from a C++ background, which is a bit contentious in the PowerShell community, but it does help you, believe me. So returned is our actual data. So what is that? So that's what was put on the pipeline. If you remember back to the script, I was talking about this custom object. So that's what's returned. It's an implicit return because there's no return statement, but it's on the pipeline. So it goes out. So $returned is my object. And we can see it is still an object. We've not converted anything to strings. So that is my output object that's come back. So that effectively gets whatever was put on the pipeline by the script block in the thread and sets it into that variable, which I then push into this array. Now, show errors is something I'm not running at the moment. That's a switch to the script, but we'll run with that again shortly when we don't use the breakpoints. Let's get rid of that breakpoint now. But I mean, we can see that job did have errors, as we said before, but we can actually get at the streams as well. So if we look at streams, which is part of the PowerShell object, you'll see the streams, hopefully, that you're used to with the right dash commands, right dash error, right dash progress, right dash verbose, where the only stream that isn't there is what we call standard output, the pipeline, because that's what actually gets returned by the end invoke call. And we can see there is actually an error here. So invoke calm is not recognized. Why? Well, again, because we're using invoke calm, which is a function, if you remember, defined within this script here, but I deliberately didn't push it into the runspace pool. I only did the invoke panic one, so that I could generate an error, and we could also see what happens if you do have a function in local scope, but it's called from a run space. It doesn't inherit it or get access to it automatically, which is why you have to do this bit for each of your functions. Now, I'd just do it in a simple array, or you could just do, enumerate, not env, function, enumerate your functions, particularly if you've got a name. Notice even drives are functions, which is quite interesting. But if you had a standard naming convention for your functions, you could do an ls and then pipe them through for each object. So you would just import your functions if you wanted them. Or here I just have a static list. But if I add a new function, I've got to remember to add it to this list, which is something I've accidentally, deliberately forgotten, just to show you the error handling. Now, so this is a synchronous call, so that will wait for the end of in this case, because we're the first iteration of the first job. But hold on, if we're going to wait for every job to finish, isn't this then going to become sequential? No, because whilst we were waiting for the first job to finish, lots of the other jobs have probably finished as well. So if we F10 this now to go round in a loop, getting rid of that PowerShell object, again, it'll just keep going round and round because they've all finished. Okay, so that's it then for running the run spaces. I've got some verbose data here, and let's actually put a breakpoint in down. Where should we put it? Oh, I've got a breakpoint there already, so I can just F5 it, and this is where we get some output. So I'll try and tally that up with the script. So you can see here's the shared variable stuff. Oops, managed to click away from it, sorry. So this is the variable that's being added to within the script block. So this is how I'm passing data other than just on the pipeline back to other run spaces and also to the parent, because they all share access, safe access, thread safe access to this synchronized array. So remember, we declared it at the top here or higher up. So say, yeah, we've got a hash table here, which is going to be thread safe. And then within the body of the script block that get executed in the run space, I'm adding it to that array so that I can then interrogate that later on. So you can see there's no overwriting of the array elements. It's all nicely in there. And so we scroll down to where that was. So that's the shared variables. These are the objects. So what we were building into this results array, which was what I got back from the pipeline or standard output of each thread, is built into this results array. So we can then see them here. Notice I've put the thread ID. So remember what I said about static parameters. So the guy leech bit is constant. I probably could have used another name. Whereas the process ID is the same. So we get the process ID dynamically within the script, where the PID is the variable. So this is proving that it's running all within the same PID. Same PowerShell process. So we're not starting separate PowerShell processes like start-job does. And then also the sleep time. So remember, the sleep time was random, which was stored here, or rather reported here, and also reported in the output object. Sorry, excuse me. So doing a few bits of quick maths, or math, if there's any American people watching the recording. Then you can see what we're doing is we're doing a sum of the sleep times. So the sum of that sleep time column. So you can see the total sum of the sleeps is 125 seconds. The actual total elapsed time, hold on, that's a lot more. Why is that? Because of all the breakpoints I've put in. I'll run this again without any breakpoints in a moment, and you'll see very different results. I count the unique threads again by grouping on the thread ID here. Yeah, so it's a good way of telling how many of each particular instance you've got. So you can see we've got unique threads. If I output that, F8, so you can see we've got those. So that was using 10 threads. So we had 20 tasks, but why were there only 10 threads? That's because the runspace pool was using the default parameters, which is the maximum number of threads in that thread pool was 10. So even though I had 20 jobs, I only told it I wanted 10 worker threads in my runspace pool. So only 10 things could run it in parallel, although running on my laptop here, I think it's a 6-core hyper-threaded, so it's potentially got 12 vCPUs, so it could potentially run 12 things all in parallel, assuming that nothing else needs those CPUs, like the Zoom session and so on. So that's why some of these thread IDs, as we can see, were reused. So the first two used the same thread ID, and we can see generally here that most threads got used. That first thread got used 3 times, and then the others, 1 or 2. So the average is about the same for each thread. Last of the information is we'd say currently have the 13 run spaces available, so we can see how many run spaces are available, as in effectively threads in our thread pool. Let's scroll back down again. Sorry for all the scrolling. By just using this get run space commandlet. You remember when I showed you the PowerShell, we had just this is a normal PowerShell window, then we just had one run space, which is there by default. So this has probably got more even than my 10 because of previous runs or other things which are multi-threaded. I then dispose of the run space pool, which is actually quite important. Normally with PowerShell it tidies itself up and you don't have to worry about garbage collection and leaks. But here, if I F5 it to go to the end, you'll see the number of run spaces now has gone from 13 to 3. What's the difference? 10. Why? Because there were 10 threads in my run space pool. So what we're doing now is I'm going to make sure there's no other breakpoints. In fact, let's remove all breakpoints and then just drop one in here. So this will now run again with all the default parameters. So we'll run 10 threads in our thread pool. We'll run 20 jobs, maximum sleep of 10 seconds. So some random number between, or integer random number between 1 and 10. And this time I won't show errors. We'll save that excitement for another run of the thread of the script. So again, let's just search for it, hash, because I can't use Control R, hash PS1 tab to search through your history for PS1, like I would Control R in a PowerShell window. So this time it's going to run through. Let's make the window a little bit bigger this time. So we'll see our verbose output that we were getting last time. But it's also timing it for us. Feel free to look at the clock yourselves. Again, we can see sort of randomish running of the, or at least output from the threads. Now that's all finished. Again, it's at my breakpoint before it disposes of the run spaces. So in the verbose output, we can see it. Well, let's look at the stages. So this is when it started firing script blocks. So that's the start of the loop. And that's the end of the loop that primes and starts running the run spaces. So that's within a second that it fires all 10 jobs. So it adds those to the run space pool within a second. Then it's going to sit and wait for each job to finish, except like I said before, when it sits waiting for the first job to finish. So in here, other jobs may have finished already, because there's no guaranteed order to these. So other jobs, other threads may have finished. So we end up actually not waiting for that long. So we can see, no, I'm not doing that either. I'm sure I set it. Yeah, look at that. I've set notifications, so those applications have been naughty. Perhaps if I upgraded to Windows 11, everything would get so much better. So we can see we finished priming our run spaces and setting our threads to run at 18:53:38. I'm an hour behind you. So that was 18:53:38, 18:53:53. Finished waiting for all the results. Yeah, that's that debug line here. So that was what, 15 seconds to actually wait for all of those 10 threads to finish. So we can see the total sleep time would have been 108 seconds. So 1 minute 48 seconds. But the elapsed time, so the difference between that 53 when everything's finished and the we'll take it right at the start. So that's when we started loading up the thread pool with our script blocks. So that's just under 15 seconds. 13 run spaces available now. Again, F5 it runs 3 run spaces available. So you can see when I don't have the breakpoints and I sit there explaining the code, we get massive speed increase. Yeah, okay, so sleep time's a really good use case here. This is just demonstrating, but I could increase the sleeps to something very large. I could say sleep up to 60 seconds, which makes it quite a dull demo. But again, the maximum amount of sleep would probably be at about 60 seconds. It wouldn't be if I ran 20 of these. It wouldn't be 20 times 600, which is 1200, which is 20 of your Earth minutes. This time I'm going to show errors. So let's do that. And I've shown you already in that PowerShell object how we can check if there have been errors. And if there have been errors and this flag has been passed to the script, then we'll actually write them to the error channel. You don't have to write them to the error channel. You could look at the errors, do things based on them, hide them from users. It's never a good idea to show end users of your scripts red errors, because they can run screaming before they've even read it and gone, oh, yeah, I was missing a file. It's like, no, there's red, help, get me out of here. So let's do a show errors on this. So that will go into that bit of the code, because as we saw when I was manually stepping through it, we do have errors in there deliberately. Of course, all my errors are always deliberate. So now start to expect to see some red. I hope. Yep. So those are expected. And there's a lot of them. well, there's going to be, yeah, as I'm running 20 jobs, there's going to be 20 errors. Now notice where the errors started. Yeah, the errors started when I started waiting for all the threads to finish. So it's not you won't see any errors up until this point because I'm manually displaying the error. You know, I could write that to the output channel, I could write that to the warning channel, I could completely ignore them as I was doing before. You know, before I passed this show errors. So in previous runs of this script, that's a switch and that was not set, so this code wouldn't have run. So probably not helping things by just pushing these out, but we can see they're all the same. Why? Because it's, you know, it's the same error in all of those script blocks. Again, not possibly very realistic, but then we can see it's interspersed with some warning and verbose, because again, I'm only running 10 threads for the workspace. Again, when we look down, we'll see again, the number of unique threads were 10, as expected, because I haven't changed the default number of maximum threads in the Runspace pool. And finish off the script, and you see it rips out our 10 Runspaces because we do the close and dispose of the Runspace pool just to be clean and tidy up. So we change. I'll not show the errors because we've shown them now. So again, you can get at the errors and other channels if you need to. If you need to pass information back other than the pipeline, you could do it through that shared variables synchronized hash table or through the error channel. Probably always a good idea, like I say, when you get your result back, depending on what it is you're doing, to check for errors like you should in scripts anyway. If I've run something, has it succeeded? Has it errored? Is it a fatal error? Can I continue? Do I need to show the user the errors? Yeah. Oh, of course I can't. Why is Zoom still? Anyway, software, who needs it? So this time I'm going to run it with maximum threads of 20. In fact, I'll run it with a maximum workspace threads of 30, but we'll still only run, in fact, we'll run 15 jobs and we'll make the maximum sleep time 15 seconds this time. Yeah, don't hard code anything, always use meaningful parameter names and always use them rather than rely on positional parameters. Good, hopefully people are still awake, although with your cameras off, you can never tell. So that's going to run the Runspace pool with up to 30 threads, 15 jobs, each one sleeping for up to 15 seconds. So again, let's look at the stats at the end. We're not going to see the errors this time because again, that show errors switch hasn't been triggered. So you can see this time, so the sum of all the sleep times in these 15 threads that I got it to roll, 15 script blocks that I got it to run in separate threads, was 2 and a bit minutes. But again, the elapsed time is only as long as the longest sleep effectively with a little bit extra, because I was saying the maximum sleep time was 15 seconds. Then no thread should take more than 15. So when we wait for the first thread to finish, which could be up to, well, in fact, the first thread was 15 seconds. So pretty much every other thread is going to have finished by the time this one finishes, as long as it's got some processor time. Obviously, if the processor is busy, then it might take longer. Notice, even though I said the Runspace pool was to be 30, actually, let's just look at the command line again here. So I said the maximum number of threads was 30. It only creates the threads on demand. Because I only passed 15 script blocks in, it only needed to create 15 threads. So that's why we only have 15 unique threads in here and only 15 extra run spaces. So again, if we F5 that, you see it's gone from 18 run spaces to 3 run spaces. So the difference being 15, because that was the maximum number of concurrent script blocks in threads that I tried to run, even though I told it could be 30. So there was room for another 15 more. And so this is, I think, more or less a 12 vCPU laptop. So it should have been able to run most of those in parallel, assuming that Zoom and other things aren't taking up too much resource. Okay, so that's pretty much it for the demo. I don't know if there's any questions. I've got a couple more slides to go through. Oh, I didn't show this, did I? In fact, let's just run the demo again. And this time, it's not full screen it, and we'll have this to the side if I can manage that. Again, you get a lot of other rubbish with DBG View. You can filter it, but let's run it again. What we should see this time is, yeah, there we go. So that's our thread ID. Oh, sorry, our process ID 71396. You can see I put it in the title of the PowerShell ISE as well. So that's another way of getting, debug information out if you need to, which you can get with DBG View or WinDBG if you run your PowerShell in there, but that's probably a bit of overkill. So that's kind of not really associated with this as such, but another way to get debug out rather than having to write to a log file, particularly if you're writing to the same log file in each of your script blocks in the thread. You would need to make sure you operate some sort of locking mechanism, because whilst we have that for the synchronization hash table for the variables, it doesn't automatically do that for any file writes. So you've got to be careful that if they're writing to the same file, that they don't write at the same time, in which case you could get overlapping data or corrupt data. Okay, so back to the slides. So the sharing of data again, which I've kind of been showing with that output that comes at the end of the script. So we said, and we saw in the script, the end invoke returns what was put on the pipeline as objects, if there were objects. Obviously, if it was strings, it returns strings. It just maintains that data in its format. And as we saw, that PowerShell streams property has the warning, the progress, the info as well, just not the output or standard output as we call it, because that's what's returned by end invoke itself. So this is just copied and pasted from that script. So you can see this is where we created this synchronized hash table as in a thread safe one. So different threads can write to the same. Well, actually, this is taken from one of my customer scripts where I have a warnings array. That's probably a better use. So if there's any warnings, I can add them into that shared variable and then output them in the main script later on. So we add that to the session state, and then I can just add to warnings, wherever I need to. So these are in the main script. This is in the script block that's running in each of the threads. Yeah. So then I have a collection at the end called shared variables.warnings, which is all the warnings from all the scripts put together. I don't necessarily know what order those warnings are in. For this customer script, it didn't matter. But the point is I can then put all those warnings out in one place rather than having to, if you remember here, if I let warnings go out to the standard output, then it's all a bit mixed, and so you've got to be more in control of those output streams. So that's why I add warnings here rather than actually using write warning in that customer script. I just add the strings to here and then do a write warning of everything in the main script. Don't need to use synchronized variables if everything's completely separate, or if everything just gets returned on the pipeline on stood out. But this can be a useful mechanism for both passing data in. Notice though, there's two types of passing data in. There's parameters themselves. So the script block that we're passing in to each run space has its own parameter block. So that's expecting parameters when it's called param1, param2, which we set here. So remember, I explained this slightly, potentially confusing bit where it makes a copy of an existing static hash table with the guide and the leech and the maximum sleep time, and then adds a dynamic one. But the key really is this line, which adds those parameters. So that's a hash table. In fact, let's just run it once more. And we can see what these parameters, if I can type it because IntelliSense isn't working. So you see those So effectively it's splatting, if you like, if you're familiar with splatting, the use of a hash table for arguments, and that's what's passing in here. So by a name, so param 1 will be Guy, param 2 will be Leach, job number will be 1, maximum sleep seconds will be 15. So that's how we get the parameters into the script, which are separate to the variables that we set within the script via that synchronized hash table. Again, hopefully, if you come back to look at the code and maybe a recording of this and run that script, so you can put your own breakpoints in, it'll help you understand how it all works. And that is pretty much it. I did mean to put some more resources in here. I've not put a huge amount in, unfortunately. So I will flesh this out with a couple more bits where you can go and look at Runspace stuff. But again, use your favorite search engine, hopefully not Bing, to go and find stuff. But this first one is, I say, from Boprox, which is where I started my Runspace journey using his stuff, and then modified, enhanced, and made it fit my use cases. So there we are. What's that taken? Oh, just about an hour or so, thereabouts, I think. If anybody's still awake or anybody's got any questions? This is Evgeny listening to music and not listening to me. Oh, yes. Oh, he's...
Yes.
Turn the music off.
Okay, no questions, but thank you. Thank you for the talk. No questions.
So I shall stop the recording now. Maybe